Welcome everybody. In our previous lectures, we have seen the basic aspects, that is the redox reaction, and after that we have discussed about the consequences of this serious problem, particularly in industry. Today we will start with the types of corrosion, and then we will be discussing about the mechanism involved in actually one type of particular corrosion in detail. From the table, it is very much clear. Basically, we can divide corrosion into two types. Number one is direct or dry or chemical type. It is called direct as oxygen is available in the environment. Not only oxygen, there are many other reactive gases which can attack metal and metallic product directly through chemical attack, that is known as direct. Sometimes it is called dry because this type of attack can take place without the presence of moisture, and that is why it is called dry, or it is chemical type. And second type is indirect. You can understand that it will not take place directly. Initially, an electrochemical cell has to be produced, and an electrochemical cell must have anode, cathode and electrolyte, and then only the reaction will proceed, and that is why it is known as indirect. And here, presence of water or moisture is a must, and that is why it is also known as wet type of corrosion or electrochemical type of corrosion. And that is why I am telling you that basically corrosion may be classified into two categories. Number one is chemical, जिसका और एक नाम है dry or direct type, and second one is electrochemical type, which can also be defined by termed as indirect or wet type. And after that, chemical type can again be classified into three categories. Number one is oxidation due to oxygen, oxidation due to other gases other than oxygen, and third one is liquid metal corrosion. Try to understand that. From theoretical definition, we have seen earlier, oxidation is addition of oxygen or addition of electronegative group. We are talking about that only. The first one is oxidation due to oxygen, and second one is oxidation due to other gases other than oxygen, and third one is liquid metal corrosion. And electrochemical type may be classified into two categories. Number one is release of hydrogen type mechanism, and number two is absorption of oxygen type. This is all about your classification. Now we will start with oxidation due to oxygen type. Let us start. Now we will be talking about the technical and mechanism involved in oxidation due to oxygen type, and therefore all of you are requested to be very concentrated. Put your concentration 100% to this topic now. This is your oxidation due to oxygen only. Try to understand that. Let us consider a metallic structure. This is your metallic structure made of metal M, and valency of metal is 2. What does it mean? It means M will be everywhere. Let us take a bigger structure like this. This will be M, 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 like this only. It is a metallic structure made of the metal M, and valency of metal is 2. Now, as M is a metal, and general property of metal is what? Under favorable condition, it will have a tendency to give up electron. And how many electrons it will give up? Because valence is 2, and therefore whenever it gets chance, it will lose 2 electron, and during the process M2 plus will be produced. As we know, if this is the metallic structure kept in the free environment, oxygen will be there in that environment, and automatically what oxygen will do? Oxygen will gain 2 electron to produce O2 minus, and after sometimes this figure can be represented like that. Try to understand. M2 plus, M2 plus, M2 plus, M2 plus, M2 plus, M2 plus. Try to understand what I am writing, please. M2 plus, M2 plus, M2 plus. You try to understand that. As I have told you, oxidation starts at the surface, and therefore all the atoms present here on the surface, this will be the surface atom. Only those atoms will undergo oxidation, and that is why this atom will remain unaffected. And यहाँ पे O2 minus, O2 minus, O2 minus, it will be like that. As all of you know that M2 plus plus O2 minus will react to produce MO. What does it mean? They will produce MO. This is your MO. And after some time, it will become like that. Try to understand that. Like this. Say M. Number of M may be less. Actually, I am not exactly follow the how many layer has gone away and how many are there. But definitely layer will be reduced. Now you see the change. All MO, M2 plus and O2 minus reacts to produce the oxide layer. This is your oxide layer. Now again, in the similar way, this will be your surface atom, and they will lose the electron M2, M minus 2e, it will be produced M2 plus, and similarly half of oxygen, it will lose gain 2 electron to produce O2 minus. Now the problem is that, try to understand, here M2 plus and O2 minus, both of them were very close to on the surface. But in this figure, you see, M2 plus is inside. If we write like that, now let us see. M2 plus, 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 M2 plus. You see, these two have not undergone ionization because they are internal layer, and therefore they will not undergo oxidation. Now this is your oxide layer. The problem is that if you compare, initially it was like that. Here there was M2 plus, here there was O2 minus. They were very close to each other, and therefore interaction between M2 plus and O2 minus was very much possible. But unfortunately here, oxygen O2 minus is there outside, and O2 plus, M2 plus is there inside. In between there is the oxide layer, and therefore now if M2 plus and O2 minus want to react again, so there are two possibilities. Either M2 plus has to come out, or O2 minus have to go in. Practically both are possible, but here in this case, it will be decided which one will go out or go in by two different phenomena. Let us see one by one. Suppose this is 50 meter distance. There is a competition A and B. Body weight of A is 70 kg and body weight of B is 300 kg. You can easily understand who will win the race. definitely A will win the race. So similarly, if we keep here hydrogen plus oxygen, definitely H2 will win. Now here we have M2 plus and O2 minus. As we know, size of cation is always smaller than size of anions, because cations are produced by loss of electron, where anions are produced by gain of electron, and therefore size of M2 plus will be smaller than that of anionic O2 minus. This is one. And number two, which is very, very important, we know that oxidation is a process in which electron is lost and at the same time some sort of energy will be produced. So due to every oxidation, some amount of energy will be produced, but the amount of energy being produced due to single oxidation may be negligible. But we know that there are millions of atoms on the surface of the entire metallic structure, and we know that all the metallic atoms present on the surface will undergo oxidation all at a time. And if we compile all oxidations together, now that negligible energy will become considerable, and that much energy will be sufficient to cause the metal to undergo melting, as a result of which diffusion of metallic atom will be faster. I repeat, two reasons I have told you. Size of cation is smaller than size of an ion, and number two, rate of diffusion of metal ions will get faster due to the huge amount of heat produced due to combined oxidation on the metallic surface. Because of these two reasons, metal ion will come out of the structure, and once it comes out, again M2 plus will react with O2 minus, and therefore MO will be produced. And this process will be continued until and unless the entire metallic structure is destroyed. This is all about your mechanism involving oxidation due to oxygen. I want to repeat only one part. Initially, we had taken a metallic structure, and we had considered the metallic structure is made of metal M and valency was 2. I have told you, M being a metal, it will undergo spontaneous oxidation. How many electrons it will lose? 2, because valency was 2. So once it loses 2 electrons, surface atom will become M2 plus, but inner layer will remain as it is. Now electron being lost by metal will be gained by oxygen, neighboring oxygen. In the process, the entire metallic structure will be surrounded by O2 minus. Now both M2 plus and M2 minus, as O2 minus being very close to the surface, they will interact, and during this process oxide layer will be produced. Once oxide layer is formed, the interaction between metal ion and oxygen ion will be restricted. In that situation, if they want to react, there will be two possibilities. Either metal ion has to come out or oxygen ion has to go in. In fact, both are possible, but here metal ion will come out because of smaller size of cation. At the same time, the total energy, oxidation energy being produced due to total oxidation will be sufficient to cause the undergoing metal to undergo even smelting, due to which rate of diffusion will be increased. And because of that, metal ion will come out. Once it comes out, there will be interaction between metallic ion and oxygen ion, and oxide layer formation will be continued. And this thing will continue unless and until the entire metallic structure gets damaged. This is all about your oxidation due to oxygen type. Next day, we'll start with our second mechanism, and before going to that, I will try to explain a few more things tomorrow in our next lecture. I hope you will go through the video very carefully so that you can understand. You can prepare your notes. You can ask questions if there is any doubt. Thank you very much.